Hi all. In previous class we have studied about unipolar scheme, and now this is the last method of polar scheme, that is RZ, that is reverse return to zero method. It is called as return to zero method because while traveling from one point to another point, the signal is traveling to zero, that is timeline zero, timeline at frequency zero. Hence it is known as return to zero method. In previous methods, the signal will be above the timeline or it will be below the timeline, but during the transmission from one point to another point, they are not touching the timeline at the middle. But here in this method, the signals are returning back to the timeline zero, hence they are known as return to zero method. And here we have denoted 0 by this symbol and 1 by this symbol. So it is the user defined symbols, hence we can define either 1 to this symbol or we can also define 1 to this symbol also. It depends upon the user. So see here we have the binary bits, that is digital data 0 1 0 0 1. So here we have to convert this digital data into digital signals. Okay, during the transmission of a data in a transmission medium, these bits will be converted into this type of signal. Hence this line coding schema is very important to transfer the data from binary bits to digital signals. So here the first bit is 0, hence we denoted by this symbol. So first bit is 0, this is denoted by low to high. So second bit is 1, that is high to low. The same way third bit is 0, low to high, fourth bit is 0, low to high, and last bit is 1, high to low. Same way we have done in the second and third example. So second example is 1 1 0 1 0 1 1. So first bit is 1, so we have taken high to low. Second bit is 1, high to low. Third bit is 0, so low to high. The same way we have drawn for all the bits in second and third example. So this is the method where the signal will return to the time axis 0 at 0 frequency, hence it is known as return to zero technique or return to zero method. So next, coming to Manchester coding. In the Manchester coding we have denoted 1 with this symbol. It have a transition from low to high, and 0 with this symbol, which have a transition from high to low. See here in this example we can see Manchester coding. So difference between the return to zero technique and Manchester coding is, in return to zero either the signal will be at lower side of the time axis or upper side of the time axis, but it won't cross from high to low or low to high. See here the signals will be above the timeline, all the 1 bit will be above the timeline and 0 will be below the time axis. But here in Manchester coding, 0 will also move from high to low, that is above the time axis to below the time axis, and even 1 also move from both side of the time axis, that is below to high, below to upside of a time axis, that is low to high. So here 0 is denoted by this symbol and 1 is denoted by this symbol. So first is 0, hence we denoted this, hence we have to draw this symbol. We have drawn 0 with the help of this symbol, that is this signal. So this signal, which is in the shape of Z, is carrying the bit 0. Next bit is 1. We have to draw this symbol. So we have drawn the symbol from low to high, that is which moves from both side of the time axis, that is upper side as well as the lower side of the time axis. Next is 0, hence we have drawn the same symbol in the Z shape. Next is 0, same shape, and next is 1, so we have drawn in this way. Next is 1, so we have drawn the same symbol. The same way we have drawn for second and third example. So here the second set of bits is 1 0 1 1 0 0 1 0. So here the first bit is 1, hence we have drawn this symbol 1, and next is 0, that is a red shape, and next is 1 1, so we have drawn the same symbol, and next is 0 0, that is the signal shape is Z, we drawn in the shape. Next is 1 and next is 0. So in the same way we have drawn for third example also. So we have the last method. We have the last method, that is differential Manchester. It is the last type of encoding. So here we will draw this symbol for 0 and this symbol for 1. Okay, but here the difference from Manchester and differential Manchester means here when there is 0 there is an inversion, when there is 1 there is no inversion. We will draw as it is. Okay, so see that here there is a first bit is 0, hence there is a inversion. For 0 we have taken this symbol, but here we have to invert the symbol, hence we are drawing opposite symbol. Okay, it should be in this shape, but 0, where there is 0 there should be an inversion in this method, hence we are drawing the opposite side, the signal to the opposite side. And next bit is 1, so wherever there is 1 there is no inversion, hence we have continued the signal. If next bit is 1, we will draw as it is, we will continue the signal and we will move as it is. But next bit is 0, here the bit is 0, hence we have drawn exactly opposite to this symbol. And next is 0, same symbol, that is we have inverted the signal. Next is 1, so we have continued the signal. So next is 0, we didn't continue the signal, instead we have drawn the symbol. In the same way we have drawn for second and third example. So let's see the second example. The first bit is 1, so there is no inversion, we have drawn as it is. So second bit is 0, hence we have not continued the signal. Here if we continue the signal it will become 1, but here the bit is 0, hence we are not continuing the signal, but we are drawing exactly opposite to this side. This is upper side, hence we are drawing from lower side. Okay, so next bit is 1, hence we are not drawing from lower side, instead we are continuing the signal. Here we are continuing the signal, so next bit is 1, so we are continuing the signal. So next bit is 0, hence we are not continuing the signal. If we continue the signal it will become, this bit will become 1, hence we are not continuing the signal, instead we are drawing exactly opposite side. So next bit is 0, hence we are not continuing the signal, we are drawing exactly opposite direction. Okay, so next is 1, hence we are continuing this signal. Next is 0, so we are not continuing the signal, we are drawing from here. The same way for third example, here the bit is 0, so we will invert the signal. Actually we have to draw 0 in this direction, but here as we see when there is 0 there is a inversion. Inversion means opposite direction, so we won't draw 0 in this direction, we will draw exactly opposite direction, because 0, when there is 0 we should invert the signal. So next is 0, hence we are not continuing the signal, we are drawing opposite direction. Next is 1, we are continuing the signal. Next is 1, so we are continuing the signal. Next if it is 1, then we have to continue the signal, but it is 0, hence we are drawing exactly opposite direction. The same way we are drawn for all the 3 bits. So in exam they will ask either 2 or 3 methods. They will give the binary set and they will ask us to draw the digital signal. They will ask us to convert the binary data or the digital data into digital signal, either with the help of differential Manchester or with RZ, that is return to 0 method, or NRZ method. They will ask any one of the method in exam. So this is the end of line coding schemas. In the line coding schemas we have unipolar and polar schemas. So in the unipolar schema we have NRZ. In the polar schemas we have RZ, NRZI, Manchester and differential Manchester.